Daryl, and this is Programming in Any Language. We are working with C# right now, but the principles are the same in all languages. Master these principles and you can easily jump to any other language quickly. Today we're going to take a look at math. I've had students that have gotten a little panicky when it comes to math. But really, it's only difficult if you're using complex formulas to solve complex problems. It's the math part that can be complex. But math can be kept simple. In C# and in any programming language, we can do addition, subtraction, multiplication, and division. There's one more operation we can do which may seem new. It's called modulus. And that's simply division where only the remainder is given. Let's look at an example. We're looking at the design mode of a math program. Basically, that's going to demonstrate how we can do addition, subtraction, multiplication, division, and modulus operations on two numbers, in the first number and the second number here. These are all named. I've named them all property. You can see I've got the exit button. It's called button exit. The button clear is called btn clear. Here we got button add, button subtract, button multiply, button divide, and button modulus. We have a label called label out. We have a text first number and a text second number right in here. The idea is to actually bring in two numbers from the user in both spots here and perform the operation on addition, subtraction, multiplication, division, or modulus and have the results appear right here. There's no code written for this right now, so we're going to go ahead and do that. First thing I'll do is I'll create the button exit button. That's the easiest one to do. One of the easiest ones. I like to get the easiest stuff out of the way, and I'll just say close form. And this will be a this.close. And that's all well and good. The clear button, I want to be able to clear these two text boxes and this particular box right here, and then set my focus on the first number. So we'll double click on the clear right here, and we'll say txt first number dot text is equal to double quotes txt second number dot text is equal to double quotes, and then lbl out dot text is also equal to double quotes. That clears it all, and I'm going to set the focus on this thing. Whoops, I didn't get that thing right here. Let's get that semicolon in there, and let's do the focus. We're going to say txt first number dot set focus, or just focus is all you really need on that thing, and that's going to do it for it. So that'll position us in that position when we want to clear it. That leaves us with basically the operations to do here. So when we think about this thing, we're going to want to bring in both numbers. We have to parse them because they're strings coming in. We have to parse them, and we'll set up two integer variables. We're just going to do integer math right now. So let's go ahead and let's go to our plus button first. We'll do an add right away. To do the add, we're going to, first of all, we're going to say read input from user. Now what I'd like to do is, since we're going to be doing this to all these particular operations, I want to put these variables up in the class area. So way up here under class, I'm going to actually go ahead and set up an int. We'll call it int first number. This will, I'll just say it holds first number. And int second number. And it will hold the second number. I also want to set up an answer. So I'm going to say int out. And this will be we'll call it the operation results. So now I've got the variables that I want to use when I actually work on this thing. So let's go back down to our add here. We're going to want to read the first number. So we're going to say int first number is equal to int.parse txt first number.text. And int second number is going to be equal to int parse txt second number dot text. That's going to bring in both strings and create a an integer variable for it. Then we're going to do the operation. So I'll say operation. And I'm going to simply say that int out is equal to int first number plus int second number. That's all you have to do for math. We want to display it, so we'll say display results. And we'll have LBL out dot text is equal to int out to string. Just like that. And that should do it for the add part of this thing. I'm going to actually do a file save here. I'm going to save all. We're going to run it to test this thing right away. See what we get out of this thing. Whoop, we got a bill there. Where is that going to be? Let's get my error messages up there. Here they are. Expect a semicolon in line 27. Okay, let's find out where that is. 27. 27, yeah, right here. We forgot the semicolon right here on the close button. So that should do it for us. So we'll do a save all and do a run. Another one. Really? Okay, let's find the error on this one. Make it a little bigger so we can see this. We have 26 has got a serious error here. Only assignment call increment decrement. Let's see what we're doing here. What are we doing in line 26? This form, this dot close. Really? That shouldn't be an issue. Oh, they forgot the parentheses right after the end of this thing. So we'll fix that up and do that. That's what I like about IntelliSense. It does fix things up for it. The error is gone now. Now we can probably do this thing and run it. You never write a program without making errors. That just is the case. And fortunately, there's a lot of tools that get those things out of you. So let's do a file save. Do a run. And there's our program coming up right over here. And we'll put in a 10, or 12 rather. And we'll tab down to here and put in a 14. And we do the add, we should see 26 pop up. And we do. 26 pops up there very nicely. So it does a nice job. These guys don't work yet, so let's do them. Subtraction is the same way. We'll go into the subtraction key. We'll double click on it. And we can copy all the information from up here, basically, and pop it right down in here and make one change to it. And that would be the first number minus the second number. So just like math in second grade, we can do this kind of thing. Let's go ahead and get them all done. Let's do the multiplication. We'll create that thing right here. We'll do another paste. And this time we'll just do a times, which is an asterisk in the case of math for computer science. And we'll go pop up here and we'll do the division right away. And put in the same code here. And this time we'll say a slash. And we're going to do one more. That's the modulus, which I'm going to explain to you in a bit. The modulus is going to be the same code, but it's going to be the percent key, which is that thing right here. What it does, if you're dividing two integers, you'll end up like 4 divided by 2 is going to end up being 2. 5 divided by 2 is going to be 2 also, and but it's going to have a remainder. The integers division won't show the remainder, but the modulus shows you only the remainder. So let's take a look at this and see. Our program's done right now, so we can run this thing. Pop it into a save. A start. And there's our program. Let's take that same thing. Let's actually do the 4. Let's make it a 5. A 5 and a 2, and do that. We can add them together. We get a 7. That works out just fine. If we do a subtraction, we get a 3. 5 minus 2 is 3. Multiplication, we should see 10. We do. 5 divided by 2 is going to equal a 2 in integer math. But 5 divided by 5 modulus 2 should give us a 1. It should give us that remainder. And it does. So the division gives us 2 into 5. It gives us 2 with a remainder of 1. But the 1's not showing anywhere. But the modulus can do that. So you really have to do two operations to get the remainder to come out of this thing and give you the 1. That's really what it does. The clear works out very nicely. We can do bigger numbers. 100 and maybe 49, and do the add again. It works great. The minus works fine. The times works great. The division works fine. Okay, look at that. There should be a remainder here as well. So we'll try that, and we get a remainder of 2 here. Really, let's just do this again. Do this to, yeah, because 49 into 100 it goes in there twice. Remainder, that gives you a 98, which gives you a remainder of 2. So it gives you the modulus right here of 2. We change this to 39 and do this now. We still get a 2 coming out of that, but we get a remainder of 22 as our modulus coming out of that. So that's how that all works. That's how math works in this particular program. We'll clear, we'll end, and that's our code. Very easy to do. All the math programs are the same, but just take a look. It's just a very, very simple, straightforward approach to doing this kind of thing. That was integer math. If we want to do math on something other than integers, we simply need to use the correct data type. The same program we just saw could be converted to handle doubles. Let's take a look. Okay, let's try something without integers. Let's make this a doubles program. We're going to do by going into the code. So I'm going to jump in there real quickly. The thing about the code when you're working with doubles is you need to change this to double. So all of our variables need to be changed. I'm going to change these to DBL here. And I'll set a double right here. So we can maybe do a copy paste, make this a little bit swifter. Notice it likes the int in here, but I don't want the int. I want DBL in here so that I know what it is when I'm looking at these variable names later on, that it's actually containing a double more than anything else. So that takes care of the variables we've got here. The first thing we did, we went up to, we don't have to worry about the clear or the exit button, but the first thing we did when we built the program last time for integers, we went to the plus button. So I'm going to jump there right away. We have a bunch of errors in here now, obviously, because we need these to be double. So DBL and DBL, and even our out's got to be DBL. And the int here, it's got to be DBL. And this one's got to be DBL. But that's all, really. We're just changing the variable names more than anything else. We do have to change this integer to double when we're going to parse it. Because we want to bring in that string variable, that the strings that are coming in by the user are, if we ended up int parsing them, we'd end up creating integers. This way we can create in doubles. We can have decimal places in these things, and this is going to work just fine. So this works great. I think like what I can do is I can do a quick copy paste on a lot of these things. Control C and lay it on top of this right away so we can cover all these guys. Did it do that? No, it didn't do that nicely. Control C, Control V. That's much better. Just got to get rid of all this red. Sometimes it's easier to rewrite the program, but in this case, I think we've got a lot of everything's there, so it's a matter of just changing the variable types, and we'll be in good shape here. Make this a DBL right away. Why don't I just copy this, and then I can do a Control C and a Control V here too, and go a little bit swifter over this. Again, we got double parse all sitting. This one's looking good. This one's looking good. And this one is going to look good in a second here. Whoops, not completely. And right up here we got this int. And remember, when we looked at this thing last time, we saw what the variables looked like, and a double has a lot more bytes to it than an integer has. Oops, DBL. So it's important you change the name of these things so that you are working with the variables that are going to be the kind you're trying to do in math. I think we've got it all. We got this thing right here. We got another double down here. So DBL. I think we're good. The system will tell us if we have any errors, but I think we're good here. Let's see what happens now when I actually run this thing. I'm going to do a file save. We'll save all here. And we'll do a run. Yep, we do have an error. So let's take a look and see what it is. And get our output out. And it looks like we're dealing with line 100. Int out does not, okay, I must say int out does not exist in the current context. Line 100. Int out. Oh, what's going on here? Oh, because it's double out. I missed one is what I did. You always miss something. File save and run it. And let's see what happens. There she goes. She's going to run just fine now. Now, I didn't format anything, so we're going to put in the number 12.5, and we're going to put in the number 9.2, and we'll do an add. And we get a 21.7 on there. It looks about right. Yeah, let's try subtraction on that. We get a 3.3. Yeah, looks like that's about right. Do a multiplication on this. We get 115 even. I'm going to trust it. We'll do a division. We end up getting a 1.3586956. Now, this is accurate. Can we get a modulus on this? We get a 3.3. Why do we get a 3.3? Interesting. We really don't need the modulus indicator when it comes to this particular thing because, you know, the division is going to work with decimals. It's going to give us a division like this, 1.355. So 9.2 goes into 12.51. One time plus a 0.35986. So modulus is something you would not use when working with doubles because it's simply looking at this from an integer standpoint. It really doesn't care. So that's the reason you have this. So this is something you would not use if you're working with doubles or decimals or anything as a variable that you would need. So in the case of this kind of thing, I'd want to go in here and I would like to make this thing basically go to my form. And I would say I'd like this thing to maybe be disabled. Whoops, let's go here and disable it. There it is. And now what happens if I run this program? That particular property is not going to let us work on modulus. So I can put in my 23.6 and my 2.98 and do a division. I get that works out just great, but the modulus doesn't work. It's highlighted. And you don't want it to work. You're not going to be using it for decimal type math. That's really what it does. Very straightforward. Math is not tough in Visual Studio or in any language, quite frankly. It's the programs you're using, you're going to be creating that can make it tough. Just like math. If you have a tough problem to solve, it could be tough in code because the formula is tougher. That's it. So math is no different, really, when working with doubles, decimals, floats, or whatever. You just need to be using the correct data type when doing the math. And as we found out, the modulus operator is specifically integer related. The modulus operator is there only to provide a remainder when working with integers. Now, adding 2 plus 2 is straightforward. What isn't is when you need to do math operations on several variables in one formula. Certain things happen first, followed by other things. There is an order of operations performed in complex formulas. Let's examine that. You can write mathematical expressions with several operators. For example, you can add two numbers together and then divide them by another number or so on down the line. But there's an order of operations how this actually is applied. As you can see on the screen here, parentheses are handled first. So anything within a parenthesis is going to be operated on first. Otherwise, exponents, x to the raised to the second power, 2 raised to the third power, cubed, or whatever. Then you're going to have multiply and divide is happening from left to right next. And finally, addition and subtraction is performed last. We can take a peek at this by just looking at some examples. Here we got a equals 2 times 3 plus 5. If we look at this, the multiplication is going to happen first. So it's going to be 2 times 3, which is 6, plus 5, giving us 11. So a is going to be equal to 11. Now, those same numbers right here, the operation inside the parentheses is going to happen first, because the parentheses is going to force this to happen. So we're going to have 3 plus 5 is 8 times 2, or 16. So while this is one number, this is going to end up being 16. A little further, we got one down here. 4 divided by 2 plus 6. The division is going to take place first. So 4 divided by 2 is 2, plus 6 is 8. So C will be equal to 8. If we look at it down here and put the parentheses around the addition, we end up with 2 plus 6, making this 8. So it's really 4 divided by 8, which is 0.5, or half. If we go a little further, we got 7 divided by 3. This is going to be equal to 2. And of course, 7 mod 3 is going to be equal to a 1, because you've got 7 divided by 3, which is 2, with a remainder of 1, so the remainder is going to be showing up here. That's your order of operations. Meanwhile, there's one last thing we didn't see. Back in that example of our program, we saw that when we divided some numbers, we got some huge decimal places in there. You can format that if you like, and there are a number of forms you can use in the two-string method that's going to help you do that kind of thing. So when you do that two-string piece, you've got those double parentheses at the end there. If you put something in it, it's going to change the results. For example, if you put an N3 on here, it's going to give you a number with a 3-digit decimal place. You put an F2 in there, you're going to format it to a 2-digit decimal place. E3 is going to give you times 10 to the 5th position, and a C is going to give you currency. It's going to give you a $sign and put all the commas in there and all that kind of stuff. And a P is going to give you a percent. So that's one way of doing it. We can demonstrate that very quickly here. If we take a look at our program we were using before, we had some answers going in here. Let's use the division piece on this thing, and let's go into that one real quickly. And in fact, let's run it first real quick and just show us what happens if we actually divide. We'll get rid of the watch this time. We don't need that. But if we run this thing, and where'd my thing go here? Let's see. There it is, right back here. If we run this, pull off the side, we'll bring it back up, get this back at its place, and then bring this on top of it. We can put in a number like 23.5 divided by 3.9, and we end up getting, if we divide, we'll end up with a 6.0256410. That may not be something we really like, so we like to format that output instead. So if we do an exit on this thing and we go down to this particular routine where we're doing the output string, we've got it right down here, and we can easily put this thing in here as an N2, and but put quotes around it too, of course. And getting too many quotes in this thing here. Okay, let's try quote N2. Quote N2, and pop it in there. Now we've got it. Now it looks very happy. So our divide is going to look like that. We'll save that, and we'll run this again. And this time we'll come up with our answer. Here it is. We'll end up with we'd use about a 12.7 divided by 3.9 and do a divide, and now we get a 3.26. So it's going to format it nicely by giving the 2 decimal places. So it's kind of handy to have. We did with currency, same kind of thing. We put this big C in there, and now we would end up getting, if we actually operate on this thing, 12.3, 3.9 divided, and it formats with the currency, $3.15. Very handy to have. So this formatting is a nice thing to use when you're working with math in C#. Okay, this is not the whole story with math, but it is a good beginning. We still have to worry about when a user enters a letter instead of a number in our program. 12 plus A doesn't compute, and the program will blow up. Same with division by 0. The computer will certainly burp when it sees that. We're going to save that for another video because we need to think long and hard about how we prevent the user from entering things we don't want in our programs. And we'll see that coming up. For now, if you understand the concepts shown so far, you're in good shape. As you work more and more with math, this is all going to make more sense. What you need to take out of this video is that, number 1, an understanding of add, subtract, multiply, divide, and modulus. Number 2, the order of operations, parentheses, exponents, multiply and divide, addition and subtraction from left to right. And number 3, the use of parentheses to make math formulas work correctly. And 4, formatting your output to eliminate long series of decimal places. We'll see this all again as we continue to work with math in our programs. And we'll learn how to prevent invalid data into our programs as well. So, see you next time. Thanks for watching. If you get a chance, please subscribe. We'll see you in the next video. Take care, everybody.